Greetings, the Astro30 here, yet again with a brand new shiny video for you. Now, sitting on my fun area in the corner of the room here, I've got this Sony amplifier. I bought it from the reuse shop, or the tip shop here in South Hobart. Now, it's a Sony stereo amplifier, and it's an FM stereo, FM AM receiver, STR-D390, and I paid $15, and its fault or complaint is no sound. What I'm going to do first is I'm going to plug it in and verify, well, that it even powers on. First, however, we'll take a quick look at the back. Here's our FM antenna in and our AM antenna inputs. Down here we've got phono, CD and tape 1, or as this era of amplifier was really trying to flog their digital audio tape technology, a DAT input. It's also got a video audio in and out, and a tape 2 in and out. So this could have 2 tape decks connected to it. And of course your normal speaker paddle type connection outputs. Impedance use is for 8 to 16 ohms only. You can't use any less than 8 ohms, because when these speakers are wired in parallel A and B mode, you're looking at a load of 4 ohm between 2 ohm speakers there. So if you use 4 ohm speakers, you're going to be loading the amplifier with 2 ohms and it won't like it. So it's got the dodgiest line cable on it ever. I mean, I don't know if you can see that, but the actual active and neutral wires are showing through the end of the plug here. So these wires have been cut too long, the cord's been, well, the plug's been replaced. And that's the dodgiest I've seen it in a while. So I've got the big boys meter out today because, well, it's easier to see on camera. I just want to check across this line cord with the power turned, which is not going to happen because that's not how it works. Just want to make sure there's no short across this power cable. No, we're in the mega ohms. So, very good. So I just need to cut this cable tie off the cord. So we'll plug it in and see what it does. I do not like this plug. Oh, it turns on. And there goes the protection relay. So, okay. As we can see, the display's lit up. And the relay clicked in, so there's no DC fault. It's just a standard rotary pot too for the volume, it's not a rotary encoder. Speakers A is on. So what I might do is I might connect the multimeter to the output of the left-hand channel and just see what voltage reading we get. Alright, so with it connected across the left-hand channel, we've got a DC offset of around about 2 to 3 millivolts minus, which is naff all. So I know the output stage is working on that side, well, at least the output stage. So it's a common earth, so I'll just switch the positive over to the right hand channel. And it's slightly higher, so there might be a biasing imbalance, but that wouldn't be the cause of no sound. So okay, we've got working power amplifiers by the looks of things. Alright, now what we should do is verify whether there is or not any sound coming out of this thing. I'll be laughing if there is. Alright, I'm hooked up with a speaker on the floor. I'm on the CD input now. No unusual noise coming out the speaker. Oh. Yeah, preamp's not working correctly. We do actually indeed have a fault. Alright. hooked up to my phone. Yep. Well, there is sound, but it just doesn't sound right. So, although I've only tested one channel, I should probably test the right hand channel now, just to make 100% sure that the fault is common to both. If it's common to both, then it can't be both power amplifiers, because they're two separate modules. So I'll just move my positive lead to the right channel output, if I can so get it in there. Oh, get in there, sod. Right, turn it back on. Yeah, it's common to both by the sounds of things. That one's even worse. So let's replay that track. Yeah, it's common to both channels, so it's pretty unlikely that both power amps will be at fault. Right, now it's time to take the top off. Here's a good look at the inside. It's pretty manky in here. It's all dusty and everything. It's like thick layer of dust, which I'm going to have to clean off at some point. That has got to be the shockingest wiring job of a AC outlet I've ever seen, although it is up to Sony standards pretty much at the time. Down here we've got a control board which allows a soft start or a soft push button at the front here, micro switch, to latch the AC input into the main big transformer over here, and it also allows a remote control input to turn it on and off via a remote. Over here is the main circuit board. Up here we've got our input selection IC. This one looks like maybe our phono preamp. Not 100% sure without looking at a schematic. Over here is two large filter caps and our output stage transistor, so it's a discrete output. And with the volume control, that's a motor. So this is a motorized volume pot. So you can control the volume via the remote. So I'll put this amplifier around about the late 80s mark. There's a better view of the output stage. Now, next question is, why doesn't it work? There's two main windings coming off of this mains transformer. One goes to a full bridge rectifier around the front down here, and then there's another set of leads which goes off to another section which is not really marked as to what it is, but it's brown with a black center and another brown on the other side. So I'm just going to measure what the AC voltage is coming out on that second connection is, because I reckon that's probably for the preamp, maybe. So if I can get in there. Only 1 volt AC, that's interesting. 3.6 volt. Okay, that might be for the fluorescent display. Because if I measure across these two pins here without touching the mains input. Oh, me. We've got 33 volt there. So I'm assuming that's the center, and across the whole lot we've got 66 volts there, which is 93 volt actually, so that's a plus minus rail of 46 volt. Also, that pop sound you heard before on me swearing was I accidentally shorted the meter probes across those two connections and it went pop. Yeah, so just be careful what you're doing. That makes for an exciting video, but it still doesn't lead me any further to figure out why we're getting no sound. So I now need to figure out how this amplifier stage works. Now, as I was just staring at this, I've just noticed there's a full wave bridge rectifier, a large one here, which has, well, that looks like the main 33033 coming in. So that's the high side for the power amplifier. Okay, so here is that power board. I have pulled it out. The AC comes in down here, goes through a center tapped primary, which goes through a voltage select switch up here, which is not on this particular circuit board because, well, the way it's configured at the moment is for 240 volt operation. The center tap would be used for 110. And we just have a single secondary winding coming out, which goes back into the main PCB, which goes through this bridge rectifier here where my finger is covering, and there's a couple of transistors here which give feedback back to this power board to turn this relay on. So this is a relay here which allows the main power rail, well, the AC to be switched through to the transformer board up here, which is the main power transformer. So that's how that works, but I'm just wondering what else they use that supply for. I'm coming up over here, following this big thick trace which comes off of what looks like the negative of this bridge rectifier. The positive goes off up there. This is really hard to see on a small screen as to what this is. Goes through a bunch of regulation transistors, and then we end up into these two transistors here, where one's minus 24.1 volt and the other one is 11.5 volt. So I've got the main power control board out of the amplifier, as I said. This is not the problem, but it wouldn't be a bad idea to give it a good damn clean. Looking at the schematic, you see those two 2-watt resistors there over on the right. They go into two separate transistors off of the B+ lines, if you like. They're regulator transistors, so I'm just wondering if these resistors are still intact, or one or both is not open circuit. So I've got to find those on the circuit board, and the D390 uses a 39 ohm 2-watt resistor here and a 220 ohm half-watt resistor here. So let me find both of those resistors and I'll just test them. Okay, it's R952, which is that one there, and R955, which is that one there where my finger is. So R955 is saying 38 ohms. Okay, should be 220, but anyway. That one's actually saying 154 ohms. Okay. Alright, I finally pulled the bottom panel off. This is in the days of amplifiers that had removable bottoms. And you see around in this circuitry here where it says reg, it's very discoloured. We look at where that transistor Q952 is, no sorry, Q951 is mounted. I just wanted to pull the bottom off to make measuring around the regulator circuitry a little bit easier to do because there's a big heatsink in the way. I don't know if the camera can see it, but the joints, where's my multimeter probe? The joints on this pin particularly, and the collector pin, they're broken. They're not making good contact. And between ground and what I assume is going to be the emitter, I'm not 100% sure, there's only 0.5 volt coming out of it. There should be 11. That's not right. The collector has the full line voltage on it, and what I'm assuming is the base over here is only getting 0.8 of a volt in it. Now if I push on it, I'm getting 13. So the first thing I'm going to try is I'm going to try touching up all the joints in this area and see if it gives us an improvement. Couldn't hurt. The thing's unplugged and turned off. I might as well touch up all the joints in that area. Some of them are not making good contact. Okay, I've touched up a few joints on the underside. Well, I don't think they fixed anything. Although the weird noise is gone now. Let's see what happens when I plug in an input. Wow. That sounds more normal. Okay. Never rule out physical. So I really need to clean the inside of this PCB area, and the output stage will probably need to be redone with all that heatsink transfer compound because it's all gone dry and crystalline. I don't know how well you can see it, but it is kind of chunky looking, so yeah, that'll all have to come apart. Okay, well I've got the heatsink out. There are no isolation washers because they're insulated plastic devices anyway, but I had to take half the amplifier apart just to get the blasted thing out. Anyhow, now I can clean this properly. I've got the transistors and the heatsink cleaned. So I'm going to apply a tiny bit of compound if I can. So I'll put my screws in, preferably not cross-threading it. One of them wasn't even tight at all, but I don't know if you saw that, but it all squeezed out. So I had to take the filter caps out, I had to take the tuner out, the back panel off, that control circuit, power circuit board again, just to get access to all the screws here. So whilst I'm here, I might as well put the filter caps back in when I find what I did with my solder. That's just a location pin, it's not actually electrically connected to anything. So I've located that one. I'll get the second one. So you can't put these in around the wrong way, so that's a good thing, I suppose. Okay, that one's in. Positive should be on that side, negative should be on that side. Yes, it is. So you can't put them in the wrong way around anyway. Okay. Done. Okay, I've cleaned the rear panel up. Now I just need to figure out what I did with the screws for it. Yeah, I reckon it's these machine ones. It would be, now I just dropped the screw. That's about 15 times a day that's happened, and it's really starting to annoy the piss out of me. Now I don't know where that went. I found it. Yes, it's real here on the Astro 30. If I make a mistake, you know about it. Oops. Just one to hold it for now until I can get the. Come on. Alright. Alright, it's all back together. See if it works. Apparently. Okay, let's play some music. Now let me select something different. Loudness. Just going to quickly switch channels. Alright, that seems to be working fine now, so I need to clean it up, put it back together. I actually want to do a oscilloscope test on this before I finish the video, but I'm going to do that part tomorrow. It's getting late in the day and I want to do something else now. However, I'll clean up the bottom cover that goes over the circuit board because it's covered in filth. And yeah, I'll see you tomorrow. Good morning, it's the next day, and I actually tested this amplifier into a speaker for about 3 hours last night, and it performed flawlessly. I could not fault it. However, today what I want to do to finalise this is measure what the actual output power of this is per channel. I only measure one channel, what's the point of measuring both? And I want to test all the functions on the front here to make sure that all the inputs are working correctly. Testing the tuner might be an issue because I don't have a suitable antenna for that, and I definitely do not have the AM plastic wire coil that goes external to this. However, I might be able to use a 2 meter long piece of hookup wire wound into a coil. Yeah, we'll find out. However, first thing I want to address is this line cord, because I am not happy with that. And I could just simply peel this back and rewire it, or I could replace the whole entire cord, which means I'd have to spend money that I didn't want to spend on this, but Yeah, if it's only going to cost me 10 bucks, might as well do it. The only problem is they use a special connector here. However, I was wondering of doing pretty much what they did, was use a 3-pin connector and remove the center pin. And I was wondering if one of these connectors had the same pitch. It doesn't fit the actual socket that's on the board, but yes, the pitch is the same. So I can go and buy one of those connectors and change it. Which means I'd have to pull this clamp out the back here, put a new cord on, wire it to a new socket, and yeah, go from there. But let me just find out how much that's going to cost me. Because what I'm going to do is I'm going to go buy one of those figure 8 double insulated leads that you can get for powering radios and stuff like that. So, and just cut the figure 8 plug off the end. That's the one I want. $8.95. Not too expensive. It's 1.8 meters in length, so I'll just cut that plug end off, strip it back, put it into the amplifier with a connector on it, and go get the socket and connector to go onto this board, rewire it, and then we continue on. So that means I've got to go out. So, fun. Alright, let's do it. Alright, and a short time later I'm back from JCar and got what I needed. I've got one of these figure 8 mains plugs, and you'll notice that it's got the safety insulation on each prong, whereas this one doesn't, which makes this plug more inherently dangerous for accidentally sticking your finger across the prongs when trying to unplug it or plug it in. Plus, it won't take long for this to be stepped on, tripped over, or whatever, before the cable's ripped out of this plug. So it's got to go. And I've got some connectors which I'm hoping are going to fit. Cost me all of about $10.30 too. So I'll just see. Yeah, that is perfect. Pitch perfect. Only issue I'm going to have is trying to get that center pin out of this connector. First, however, I've got to get this line cord out of the back panel. And I don't really want to have to take the back panel off again to do it. It's coming. I'm just hung up on one clip. Oh, there it goes. Alright. And a power cord is born. And this dangerous mess can disappear. And I need to take this power PCB out so I can change the connector. I forgot to connect up this socket back to the board anyway, so makes it easier. I would have eventually noticed it. There we go. Okay, I got the cord done. I couldn't pull the center pin out of this connector, so I've just cut the end of it off flush as possible to the body of this nylon. So now I can take this connector off and change it. Is that soldered enough to pull out? Let's find out. Yep. So now I can stick the new one in the same way around. Fits like a glove. Pity about that extra pin, because there's a little bit of a knob preventing this from going flush with the board. I'm really going to have to try and get that out. Alright, got it out. Let's try that again. Yeah, that fits much more flush. Might as well touch up the joints on this board too. I don't want this board failing because of a bad joint. Especially around this transformer. Alright, and that's complete. And now we have, if I plug it the right way around of course, we have a working connector. I mean, yeah, these connectors aren't really the best and there's nothing to align the center, but it does the job. I'll put it back together. Get in. There we go. One new power cord complete. Excellent. Plug this one back in before I forget to do it, which I did last time. Plug that back into there. Plug the transformer back in. Now I just need to confirm that it works. Alright. Excellent. Right, very good. That looks all very good, clean, as clean as I want it. And it's got a nice, safe plug on it now. Alright, now to do a power measurement test. Alright, got everything set up. Amplifier's on CD. It's turned off currently. I'm connected across the left channel. Let's see what happens. Alright, can't see anything yet. Now I can. So far it's a clean waveform, 54 volt peak to peak. Oh, clipping there. Drop the amplifier's volume down a bit. Okay, I'm saying that we're looking at 64 volt peak to peak before clipping. Right, so that's going to be 32 volt peak multiplied by itself divided by 8 ohms, that's 128 watts peak. So 32 multiplied by 0.707 to give us the RMS value. Multiply that by itself. 624 equals that divided by the load. 63 watts. So I'm going to say it's a 60 watt per channel amplifier RMS into 8 ohms. Right, so that's that test complete. And it passed. Right, so now I need to test every input, make sure it works. So I'll switch over to tape monitor, which is not that one, that one. Right, we have a signal on tape monitor. We go to video, for instance. Alright, take it out of tape monitor mode, yep. That's the tape record out, so I know the output's working. So is that one on the DAT side. So DAT input. Yep. CD we were on. Phono, this is going to distort to hell. Yep, it's working. And that's the tuner. Right, that heatsink was getting quite hot. Yeah, but I've done the stress test now, so I don't need to do that anymore. And as for an FM antenna, I've just got a couple of alligator jumper leads connected. See if that works. Probably not. Actually, it might do. Let's see how we tune this thing. Doesn't have any presets. So tuning. Okay, can't play too much of that. Okay.
And their culture will be a gift to their country.
Okay. If you say so. Nothing. Just check it's coming out the other channel. Huh.
To the Australian Parliament and the
Well, that's interesting. There's no output on the right-hand channel of the tuner. Don't know exactly why.
Brandon Lake, and he talked recently about.
Well, there is there. Sounds like it's got a bad joint. That made it work. Seems like the tuner is working, but it has got a slight issue. But I will check the joints around the connector. I'm going to pull the bottom cover off again anyway, make sure all the joints are good under there. I only just got it working yesterday. And that's pretty much the end of the FM band. Yep. Okay, let's go to AM. I don't know if I'm going to tune anything in. No, I'm going to need a piece of wire as an antenna. That's my solution. It's messy and crude, but it might work. It's basically what that plastic thing is that connects the back of stereos. It's just a coil of wire like this.
I think there was a level of
Yes.
surprise from the European side that they thought that we were
Works.
just fluffing.
That's right.
Beef stock task, yeah, delicious. S2, because if you make it too creamy, it's.
That's basically the end of the AM band. It doesn't pick up the racing channel. Or what's at the lower end of the band, it's not the right type of coil. But it is actually picking up radio reception, which is good.
Paddy, is that something that you ever had watching?
No, but.
Question is, do I need that coil of wire?
That's Brussels flat, but the cable thing being with bubbles.
No, I just need it connected somewhere.
I know most people think it's at the leftover thing.
There we go. It only needs to be connected to one end of this. That's fine. That end's the ground anyway up here. Sweet, now I need to have a look into the tuner and make sure the joints are okay in it. Tuner board's out, and yep, some of the joints are bad on the connectors. So I hope that's physically connected. I think it is. That one's especially bad. Alright, it's back together for the final time. I even soldered the connections on the power transistors underneath just to make 100% sure, so I'm not going back in here again. It's currently on AM, non-copyright. It's working on the right channel. The only thing I haven't tested is the speaker switching. I've already tested the headphone socket last night. I know that works, so we can skip that. So A out, A in. Right, B in actually cancels A. That's interesting. Alright, let me swap the connection to the second channel. Right, so let's try. Okay. You can have B speakers on but you can't have A at the same time. Interesting design. So I'll just check the left-hand channel on B as well. Yep. Go over there, and yeah, with B turned on, A turns off. Well, it must be right. I can't see a reason why it wouldn't be, but alright. And there it is, all there, back together, cleaned and detailed, ready to go to a new home. I'm planning on selling this on the internet. I reckon I should be able to get around 50 to 80 bucks for it back. I've got $25.30 invested into it, so if I end up with 50 bucks back for it, I've made a $25 profit. And some of you may disagree with my methodology of my fault finding. I will stress that if you've got an issue with any of amplifiers like this, for instance, it's completely dead. Well, first thing you should do is always start at the power supply and look for, you know, something simple as a blown fuse or an open primary on a transformer, stuff like that. That's why I did it the way I did. Plus, I know these Sony amplifiers, and when you start getting digital noise on the output, when you rotate your wick all the way up, and either no sound or a distorted sound, that's a good indication that there's a problem with the preamp. And because it's common to both channels of both the preamps and the power amps, that's indicative of a power supply rail that is missing, which is indeed what we found. And anyway, that's how I did it 26 years ago when I used to be in the service field repairing amplifiers like this. I always measured voltages. That's what you should always do. Anyway, this video's gone on long enough. I hope you enjoyed it, and if you want to see more videos of me rescuing stuff from the reuse shop and trying to repair them and flog them off, leave a comment below or even a big like on the video. That'd be great. Helps me know that I'm doing something constructive. See, the thing is, I want to bring different type of content to this channel rather than just me building stuff and, you know, messing about with electronics. And even though that's fun in its own right, I have thought for the last couple of weeks that I want to go back to what I used to do before I started this YouTube channel, was buying stuff from the tip shop and fixing it up and seeing if I could sell it off. And that was a good 8 years ago I used to do that, and I kind of missed it, so I thought I would go back to doing it. If you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and become a Patreon member for as little as $1 a month. Links are in the description as usual, guys. Anyway, this is Yastro30 saying see ya, have a great day.